topic is going to be focusing around integrating your backups, boring backups into your CD, your GitOps pipeline. So think about, like, even if you're not a software developer, even if you're working on the infrastructure side, the platform side, and you're releasing a version of your application going from version 1 to version 2, but before I go to those versions and change that, I want to make sure that we've got a backup of that data so that we can roll back just before. So you don't need to know who I am. So if we think about CI is not really the topic of what we're going to talk about. If you are software developers, you're going to be familiar with this process where someone builds it, software developer builds some code, puts some codes together, probably stores it in a version control system like Git, and then probably uses something like GitHub to store that source code. Then they're going to build it, they're going to test it, and they're going to store that up into some sort of repository, maybe something like Docker Hub, for example, right? Okay, there's no data there. You're probably doing some testing with some data. You're probably storing maybe a database that makes up your application, but ultimately, everything is ephemeral at that point. We don't really care. It just gets us from A to B. Where it gets quite interesting, and this is where you don't have to be a software developer or a software development house developing your own software, is when we get into the release of software. If we look at the likes of like Microsoft and Oracle, they're releasing their software as container images, off-the-shelf software that you then just go and deploy. And their release cycle is much faster than maybe the yearly cycle that maybe we're once used to. So we're seeing it a lot more frequent. Now and they're just two vendors that I'm mentioning, but think about all of your software stack, off-the-shelf software that you then want to deploy inside of your data center. So from a continuous deployment or continuous delivery point of view, we're going to get this release cadence, we're going to get version 1, version 2, and we want to be able to push that into our environment. Now I'm using Kubernetes as my platform, and just think about Kubernetes as another platform, whereas like we have EC2 from a virtualization point of view, we have VMware on premises, we have VMware in AWS, etc. I'm using Kubernetes just because then I want to highlight how we're integrating that into Kasten K10. So ultimately, this is really relevant to anybody. It doesn't have to just be software development or software houses. So if we think about this, we probably got a group of platform engineers or infrastructure admins, sysadmins. We're all called very different things, right? And we might have our application stored maybe off the shelf. In this instance, I'm going to be using literally a MySQL, I think it's a MySQL, maybe Postgres database that is stored, the whole application is stored in Git and then in GitHub as a repo. I'm going to use an open source tool called Argo CD, which then deploys my Kubernetes application into my Kubernetes cluster. Actually, I think this is using EKS as a cluster. Now, that's fine if this is just a front-end web application, then there's no database or data service that we have to worry about. Where it gets interesting is when you've got a database and you're pushing some important data to that database. And we've got external users that are in control of that. They're the one, and in which case that data, the database and the tables and the schemas that are stored in that database are not in this source control anymore. They're not on the off-the-shelf software. We've changed. We've manipulated that data set. So even though we've got the source code for the application and we can bring that back if bad things happen, we don't have the database. We have to think about that mission critical data that we're storing in that database. So if we were to lose that persistent data, it's not captured in version control. And that's the key part of what I want to touch on today is if you're using an application, generally speaking, it's going to have some sort of data service attached to it. And how important is that data? Now, you might argue, you might say, well, it's not important, I don't care. It's a login system, I don't need that data. That's fine. Then we don't need to protect it. But I argue that a lot of that data will be important, but maybe we just don't have an easy way of automating that backup through that process. Okay, so it's all about the data. So lots of words, but ultimately, in this application, we've got Postgres. Postgres databases, they can live anywhere, whether it be on a virtual machine in EC2, whether it be using RDS. whether it be using a stateful set within Kubernetes and a persistent volume claim, which is the route I've taken in this. But ultimately, that could be an RDS instance holding my Postgres database. It's on a persistent volume within our Kubernetes cluster. We're going to trigger a backup action so that we've got a good copy of that data. Not just a good copy, but an application consistent copy. So we all know what happens if you pull out the power cable to your PC at home. It might come back up, but there's a risk that it won't. So application consistent is going to make sure that everything is coalesced and everything is in a good state, that when you put the power cable back in, the database comes back up and all that data is still there. We're going to store that then into S3, into a S3 bucket. I'm not actually going to store it there because it takes a bit of time then to recover in the demo. Okay, so before I show you the demo, I'm going to just highlight what we're actually going to show. So I've got my application stored in GitHub. I have a Kubernetes cluster. I have Kasten K10 deployed in there. I also have Argo CD. We're going to deploy our application via Argo CD, which is then going to create our application, which consists of a deployment, a pod, a service, a PVC, as well as a stateful set that stores data on an EBS volume, where we're storing our Postgres database ultimately in there. We're going to have a stateful set that runs our Postgres container. We're going to have a user, and we're going to go from version 1 to version 2. We're going to then release that. But what we're going to do in that release cycle is we're going to trigger Kasten K10 to just, before we release that new version 2 into the system, we're going to trigger a nice clean backup, an application consistent backup, before we commit that changes. So we're being a bit more dynamic at this point. It's like we're not relying on infrastructure teams, operations teams, and the backup to happen at 6 p.m. and hopefully it finishes before the morning. This is being more dynamic and making it happen as part of the flow, as part of that GitOps cycle. We're going to take a snapshot. This is how far we get in this demo. But we could export that out into object storage as well. I don't do that. Snapshots are great. They shouldn't be just used on their own as a backup, but they're a really fast recovery point. But if you really want to adhere to that 3-2-1 rule, so 3 copies of your data on 2 different media types and one of them being offsite, that remote storage, that maybe AWS S3, is that offsite copy. It's going to be able to protect you against that snapshot going bad or not being available. So we're going to sync that version 2 once we've done the backup. But what that's going to do is maybe a junior has taken a Kubernetes job and they're going to manipulate that data set. And all I wanted to do was add a new line item, and actually I just zero all my data out. So simulating a failure, a manipulation of data, accidental problems. We've all done something silly in our day-to-day where we delete or make an accidental change. So ultimately, meaning that our database now is not serving the right amount of data or not showing us our mission critical data. So what we're going to do is we're going to use Kasten K10 to restore that application plus the database. And let's get into the demo. So hopefully, yeah, okay. So like I said, we've got that Kubernetes cluster. By the way, I'll have a QR code, so when you get home, if you want to run through this, you can do. So you can see here that I have Kasten K10 deployed within our cluster, as well as Argo CD. Just down here is some port forwarding, just so I can get access to it. We're going to deploy our application, that stock demo application. So, and now I'm using Argo CD. This is how we're going to deploy our application. So stock demo, project name, what do you want to do sync policy-wise? So if we're updating that product, we could do it automatically. We're going to point it to our repository URL that I just showed you in GitHub. We're going to send it to our Kubernetes cluster that Argo is on. This could be a remote, and we're just going to recursively go through that folder structure. So we're manually syncing that. So what it's going to do is going to go and create that new namespace and deploy that application that looks like this. So it's going to have the Postgres SQL, this is the stateful set. But you see here, before we've even deployed our application, we're actually going to take a backup straight away. So eventually, past me, it will eventually kick in and take that backup. And all we've done here is just triggered a dynamic version or a dynamic instruction to say, okay, before we do anything, pre-sync this and take a backup. So it's a bit pointless us doing this first one, but because we've implemented that into our application, it's always going to do it. This is a good way of testing whether the backup is actually going to work as well. So eventually this will kick off. And if we go and look now, what we have done is we have created our namespace stock demo, but there's nothing inside it. You see there's no other than a Kasten precinct pod or job that is running. Here we go, we started the backup process. Now this should be pretty quick, right? There's nothing in there. When you create a namespace in Kubernetes, it brings about 5 or 6 or 7, maybe a few more, very basic artifacts. So it'll bring a role binding and a few other things that you saw there. Now what does this is in the Argo CD file, we created a Kasten precinct job that does this presync and uses a sync wave. Now that's specific to Argo CD, and that enables us to trigger that. You saw it was very quick, and we just captured seven artifacts within that namespace. So then what happens is we're going to implement a change. But before I do that, I need to show you actually the application. So I'll jump on that in a sec. But what we're going to do is we're going to use that job template to manipulate that data. And what I want to do is I want to add a new line item and stock level to my database. Now, instead of that, if anyone saw it very quickly, is that I'm basically taking a template that is going to zero out all of my stock items. That'll make sense when I show you it in a second. So this is a common occurrence, right? This is using Kubernetes jobs to manipulate our data via a config map, via a secret. This happens on a daily basis. So we're going to actually commit that into our GitHub repository, our application repository, and push that up into that. So once that's done, remember we set Argo CD to manually sync. So everything's green, everything's good. So let's jump now into actually looking at so you see in our repository we've got new stock job, which is the bad change. Now let me actually show you the application. So you see here everything's running. We've got a stock demo and a Postgres. We should be forwarding our application now. And very simple stock demo app. So if we jump onto that, Okay, so then you get to see we've got our products, we've got our availability and our stock level and prices. Let's make some changes here, some random numbers. I think if we just remember Veeam VBR vol as 4531, that shows how many times, 1431, that shows how many times I've run through this demo. Okay, now we're going to sync. We're going to sync that bad change into our application, which is going to manipulate that database. But before we do that, we're going to trigger that pre-sync job again, so that we've got a good copy of what we just changed in that stock app. You see here as well that I manipulated that job that manipulates the data. I also used a pre-sync wave because I want that to happen after my backup job before we deploy the updated change into our application. So again, this is pretty quick, but the importance of showing this is that, remember, this is V0, like nothing happened here. There's no point in rolling back to this because there won't be any application there. But this one is our version 1. Our application is running, and this is where our current stock app is at. And you see here that we've got 16 artifacts. So we've now got the persistent volume claim, we've got our deployments, we've got our stateful sets, we've got our secrets, etc., that make up our application. So what I'm doing here is, so I've realized I've made a mistake, so I'm just setting up to fix the stock app, the Kubernetes job. Okay, good stuff. We've got our version 1 backup before we've gone to version 2, which is where we're adding that new line item. Okay, bad times, our availability's been zeroed out. We don't have that 1431 for VBR anymore. So we come into K10, we find our backup, so this is our snapshot. You can see that we have one here, which is at version 0, and then we have our latest version 1. What we can do here, I've just triggered that backup. Now, I'm just restoring everything because I'm panicking. I just need to get my salespeople just to start selling again. Now, but I can be granular about what I actually recover using data. I can specifically say, I only want you to bring back the PVC. I only want to bring back the database. But I was panicking, so I just brought everything back. So what I'm doing here is I'm going to remove that new stock job that the intern did, made a mistake, mistakes were made, and I'm going to put in the right one. I want to add a new line item. I want to add in, I want to add in Veeam backup for Salesforce with our stock app, or with our stock levels for that. So basically, I'm adding that in. I've now removed the mistake. Maybe someone a little bit more senior is adding the data this time rather than the intern. Again, we run through that process of committing that with a nice commit message, best practices there, and then pushing that to our GitHub repository. Okay, so the restore's complete. So now what I want to do is let's port forward that again. Let's go and look at our stock demo app, make sure that we're back to where we were, 1431, good stuff. Okay, so now we're back to where we were. We're back to version 1. Now we're going to go to version 2. Again, we're going to have to trigger that back up again because maybe other transactions have happened since. So what this is going to do is now insert only that new Veeam backup for Salesforce line item. So we manually sync it. Again, that could be automatically synced. In fact, a lot of people will use that automatically sync because, again, you might have 100 different applications. Each of you will have a different amount of applications in your environment. So what we're going to do first is that same old story. We're going to take that boring backup that saved us a little while ago. And again, we're going to pick up the persistent volume claim. Again, it's just going to be a snapshot as well. But we could export that into AWS S3 as well for a copy of that data. So this shouldn't take too long at all. So once this backup's finished, we're then going to sync that job, which is now going to add that new line item. And if all being well, and we haven't made another mistake, we should just be able to go to our stock app and we should now see our new line item in there with its available stock so that our sellers can get out there and sell some stuff, make us some money. And I think the overall premise of including this, one, we haven't had to, so we might also, from an operations side, we still might have that every hour backup process. But what this does is just protects for those minimal changes between the versions, being a little bit more dynamic. You see there that we've got our Veeam backup for Salesforce. Okay, good stuff. So, yeah, the premise there is that we can just include or integrate that into our CD pipeline, into our application deployment. Now, I mentioned all of that is on GitHub, so anyone can go through this. I've used it with Minikube as well, so you don't have to spend money to get a Kubernetes cluster to play around with it. But if you scan that QR code, it will take you directly to that GitHub repo, go and fork that, and go and play around with it. Yeah, with that, job done.